Welcome to EDU World Space.
So what we have here is a rock being thrown off a building at a velocity of v naught at an angle of alpha naught above the horizontal on top of a building of height h. Now what we need to do is we need to find the final velocity at this point, and we are going to show that the velocity is independent of alpha naught. So what we're first going to do is we're going to find the horizontal and vertical components of this projectile. So let's take the vertical component. That is just going to be v naught sine alpha naught. It's sine because it's on the opposite side, and that is equal to v naught y. And then for vx, v naught x, which is the same as v final x, because it's in the x direction, there is no acceleration. That is just going to be equal to v naught cosine. Let me write it down here. It's going to be equal to v naught cosine alpha naught. So now we're going to use one of our kinematic equations. V final in the y direction squared equals v naught y squared plus 2a delta y. So for delta y, it's going to be the height, but since delta y is y final minus y initial, we end at y equals 0, and we start at y equals h. So delta y is actually going to be negative h. So delta y equals negative h. Acceleration is the acceleration due to gravity, so we're just going to call that negative g, where g is 9.8 meters per second squared. And we can solve for everything else. So v final in the y direction squared is equal to plugging v naught y, v naught squared sine squared alpha naught plus 2gh. All right, we're going to keep it like this, and we'll see why later on. Now, let's make our triangle. Here's the x component and the y component, and we're looking for this diagonal, and we're going to find the diagonal by doing Pythagorean theorem. So that is going to be v is equal to the square root of v final in the y direction squared plus v final in the x direction squared. Now if you look, the v final is already squared, so we can just plug that in. So we have v is equal to the square root of v naught squared sine squared alpha naught plus 2gh, and then plus the in the x direction squared, that is just going to be v naught squared cosine squared alpha naught. Now we can plug that in. So we have v naught squared cosine squared alpha naught. Now you'll see we can combine these. We're going to take these two, factor out v naught squared. So v equals the square root of v naught squared times sine squared alpha plus cosine squared alpha, and then plus 2gh. Now you see the sine squared plus cosine squared, that just equals 1. So we can simplify this to v, velocity, is equal to the initial velocity squared plus 2gh, all of that square rooted. And that is our answer, and you'll notice that it is independent of angle alpha naught, as it does not appear in this equation for velocity.